everyone, this is Gauzar, the self-proclaimed physics detective. Today I'm answering a question raised by a viewer like you about a video that I made about the destructive power of the Death Star. You can find a link to that video down in the description below. Anyway, the question can be summed up like this. How feasible is it to generate the needed amount of energy? One thing to keep in mind as I go along is that there are several details that I'm not going to mention in order to keep this short. If you're interested in a more lengthy discussion on anything mentioned in this video, let me know in the comments below. So, to quickly answer that question, let's consider 3 energy sources: gasoline, plutonium, and antimatter. First off, in order to produce the necessary amount of energy from burning gasoline, you would need to burn a minimum of 2.6 septillion gallons, or enough to fill the Earth's oceans over 7,000 times. Next, the required amount of energy could be found by fissioning 4 quadrillion tons of plutonium. That's enough to make a ball of plutonium measuring 64 miles across. Lastly, the necessary energy could be generated by combining matter with antimatter. For those who aren't familiar with antimatter, it's a lot like regular matter, but opposite in certain ways. For example, protons and electrons have positive and negative charges, respectively. Their antimatter counterparts, the antiproton and the positron, are negatively charged and positively charged, respectively. What makes antimatter so special is that when a particle of antimatter combines with its regular matter counterpart, the result is pure energy. In order to produce the energy needed, it would take 1.9 trillion tons of matter and a corresponding 1.9 trillion tons of antimatter. That's just a bit heavier than Saturn's potato-shaped moons of Pandora and Prometheus. So let's get back to the original question. How feasible is it to make such a massive amount of energy? Well, gasoline is out, considering that the amount of required gas would be larger than the Death Star itself. Nuclear isn't so bad in that only about 1.5% of the Death Star would have to be filled with plutonium. But keep in mind that the amount of plutonium previously mentioned would have to be consumed for each and every shot. Finally, there's antimatter. In terms of size and space requirements, it's far and away the best. The biggest challenge, however, that this method poses is the lack of antimatter in the universe. That being said, there are ways to manufacture it, so it's still arguably the best option. Well, that's all the time that I have for today. I hope you found this video illuminating. If so, then why not click like and maybe even subscribe to my channel. Anyway, this is Gauzar, the self-proclaimed physics detective, signing off.